Right. So yesterday, that model which I have discussed is a very, very important model. All these questions I have done in my previous day's class. Let us take some more models. This is a very famous model. It is called conveyor belt model. The name of this model is called conveyor belt. It is the conveyor belt where you will see is in airports, where the belt will move like this, upon which we will drop our suitcases, our baggages, and all that. And that will move all along that U-based platform, where the passengers picks their concern luggage. See what is happening here. What time you are supposed to come? Why you are coming now? Stay outside. Now this is the conveyor belt, which is moving with a velocity v, and this is a block dropped on the conveyor belt. ఇప్పుడు ఇవన్నీ తగ్గాలి అంటే ఓన్లీ సొల్యూషన్ ఆ 10 మందితోనే పాట చెప్పుకోవటమే, లేకపోతే ఈ తప్పదు. బ్యాచ్ అంటే అది చదువు ఇంట్రెస్ట్ ఉండదు. వాళ్ళ అమ్మా నాన్న ఫోర్స్ చేస్తారు, జాయిన్ అయిపోతారు. వీళ్ళు కూడా వేరే ప్రోగ్రామ్ ఇవ్వకుండా ఇదే టాప్ ప్రోగ్రామ్ అని ఇస్తారు. తప్పదురా వరుణ్గా. నెక్స్ట్ వీక్ వ్యాట్ బేస్డ్గా ఐ విల్ క్లాసిఫై బ్యాచెస్ ఇంటూ 2 categories. ఫిజిక్స్ క్లాసెస్కే నేను మిగతా క్లాసులు ఓన్లీ ఫర్ దట్ సెట్ ఐ విల్ టీచ్ దేర్ ఇన్ మై రూమ్. No disturbance, and very fast I can even do that. You have placed this block. You just dropped this block. Actually, this is moving with a velocity v. Conveyor belt is moving with a velocity v. Now, if I am an observer attached to the conveyor belt, what I will notice is that the block is having a velocity v in this direction. The block will have a velocity v in this direction. Got the point? అక్కడ ఓకే కొట్టు. ఓకే, అక్కడ ఫుల్ స్క్రీన్ కొట్టు. వ్యూకి వెళ్ళి వ్యూ పైన వ్యూ. రైట్, గుడ్. కాదు, ఇంకా ఆప్షన్ ఉంది నీకు అక్కడ. ఇంకా పైకి వెళ్తే రైట్, గుడ్. Now, this block is having a velocity v leftwards. This block is having a velocity v leftwards. Now, obviously, on the block, the friction acts in this direction. That is how friction acts. Now, what is going to happen is that it will undergo some deceleration and hence comes to rest. So you use v square minus u square is equal to 2as. Final velocity 0. Initial velocity of the conveyor belt 2 times. In fact, there is no acceleration, there is a deceleration actually. What is the frictional force? Of course, since there is a relative slipping, you can write F as mu mt. It is no longer static. Why it is no longer static? Because there exists relative motion. So therefore, minus mu g into s. So finally, s is v square by 2 mu g. That is the first part of my question. Remember, what is this? Displacement of the block with respect to conveyor belt before it comes to rest. So what is the frame of reference when you are solving the entire problem? You are attached to the frame of conveyor belt. Remember, you do whatever you want, conveyor belt all the time moves with constant velocity. What is the difference between the problems which we have done previous day and today? Varun, టైము పొదుపుగా వాడుకోవాలి, టైం ప్లాన్డ్గా వాడుకోవాలి. నిన్న 1 hour క్లాస్ ఎందుకు చెప్పాను ఎక్స్ట్రా? వీళ్ళకేమో బ్యాకప్ నడుస్తూ ఉంటుంది, మీకు ఆ బ్యాకప్ టైం వేస్ట్. దాన్ని నేను ఎలా వాడా? హయ్యర్ ఆర్డర్ ప్రాబ్లమ్స్కి వాడా. ఇవాళ కూడా బ్యాకప్ ఏదో ఒకటి ఇస్తారు వేరే సబ్జెక్టు. మనం ఆ టైంలో నిన్నట్లాగా, నిన్న బాగానే ఉందా డిస్టర్బెన్స్ లేకుండా త్రూ అవుట్ ఈవినింగ్ క్లాస్. రైట్, ఎంతమంది విన్నారు నిన్న ఈవినింగ్ క్లాస్? ఒకసారి చేయొద్దండి. అంటే బ్యాకప్ అవసరం లేని పిల్లలు 1 2 3 4 5 6 7 8 9 మెంబర్స్, 10 11 12 చాలు, ఈ క్లాస్లోనే పెట్టాలి, తప్పదు. Why I am discussing this is because if it is a lesson number, I would have conducted there. There won't be any disturbance at all. Right, done. So, you want the same thing to be answered with respect to the belt. I've done this with respect to the belt. Remember, with respect to ground, what is happening? That also I will discuss. Right. So there is no confusion, and I'm very strong in doing this question, remember. Now, in this case, observer is with respect to conveyor belt. Ikkada observer is on ground or ground observer. For a ground observer also, friction acts like this only. Why? Here, with respect to conveyor belt, relative motion is backwards. Friction opposes relative motion. So block experience forward. What is the difference between the observation taken by an observer on ground versus the observation taken by the observer attached to the belt? Any student in this class, what would be the difference? I repeat my question. What is the difference between the observations taken by an observer with respect to ground versus an observation taken with respect to the frame attached to the conveyor belt? With respect to the frame attached to the conveyor belt, it slows down and comes to rest. With respect to an observer attached to the ground, it starts from rest, reaches a velocity v. Once the block reaches velocity v, friction disappears. Why? There is no relative motion. So therefore, with respect to an observer, the acceleration is plus mu g. Right. So use the same formula. V square minus u square is equal to 2as, which implies 0 minus v square is 0. No, sorry. I'm wrong. Because final velocity is v, initial velocity is 0 here. Final velocity is v square minus 0 is 2 mu gs. So which implies S is equal to V square by 2 mu G. Sir, I think I am sensing something wrong because you have given both observations. No, I am absolutely correct. So I should say this one backwards. And I should say this one as forward. Since this is backwards, you have a minus answer. Since this is forward, you have a plus answer. That's the difference. Now you may ask me time. No issues. What do you want? Time, right? Okay, in this case or in the previous case makes no difference. You will use V is equal to U plus 80, which implies V is 0 plus mu zt, which implies T is equal to V by mu G. Okay. Now open to you. Any doubt? Please ask me. If you have any doubt in this, you please ask me. Boys and girls, do you have any doubt in this? Pakka? Sure. శ్రీమాన్ ఏంటాలా నువ్వు శ్రీమాన్ అంటే వీడు నువ్వు నీ పేరు ఏంటో మర్చిపోయాను ఫాలో అవుతున్నావా మొత్తం చేయమంటే చేయగలుగుతావా షూరా మ్యాక్సిమం ఎందుకు చేయాలి వింటలేదు నువ్వు నెక్స్ట్ ఐ విల్ పోస్ట్ దిస్ నోట్స్ ఇన్ ద ఈవినింగ్ టేక్ ఎ ప్రింట్అవుట్ ఆర్ upgrade it later. Time is the criteria. That's what I am working about. Right. Last week we failed in filling the notes. Don't forget. All inclined plane the other day. Yeah, we'll take up this case now. Go through the question, please. Two blocks A and B are connected by a light string of inextensible string passing over a fixed smooth pulley as shown in the figure. Coefficient of friction between the block A and B is mu is equal to 0.5. If the block A is just to slip, find the ratio of the masses. Angle is fixed here. You know this. Can you please forget about the right hand part of the diagram? So I will see that in that case it is as same as so this is some force F which makes an angle theta. I have done this on very first day's class. It's a pulling force. Now what is the expression for the block to move? Mu mg. Do you remember this? Yes or no? The general formula mu mg by cos theta plus mu sin theta. Do you remember this? That's all. Left half is this. Right half in the place of F, I need to write. Correct. MBG. So therefore, now I'll change the color. MBG is equal to mu times MAG divided by cos 37 plus mu 1 by 2 sin 37. And there is no issue at all. You can cancel these two. So MB is finally half of MA by cos 37. Cos 37 is 4 by 5 plus a half of 3 by 5. So if you do proper calculation part, you will have 5 MA followed by 8 plus 3, 11. So which clearly implies MA by MB is nothing but 11 by 5. Right. Any doubts? Right. In the arrangement shown in the figure B is a ball of mass M. There is a hole, posa. There is a hole in the ball and the thread passes through it. There is some friction between the ball and the thread. The other mass, capital M, which is greater than small m, is tied to the string. The system is released. Find the acceleration of capital M. Let us try to draw the free body diagram of tension T. ఇప్పుడు ఇది కూడా is a small board actually. We have ordered a new one now, which is Bluetooth, wireless, and bigger size. I won't compromise on the quality of my inputs. You should also do the same. Do not compromise on the quality of your outputs. Right. MG. Sorry, capital letters required. And say this as acceleration A. You said the ball is remaining stationary, which means between the ball and the thread, there is the system is released, the ball remains stationary. The ball remains stationary with respect to ground. How is this possible? It is possible. See, this ball which is available here will not allow the thread to pass through the hole. That is friction, right? So this will exert a downward force on the string, whereas the string will exert an upward force on the ball. Convinced? Right. So this will experience an upward force, which is same as the tension. And mg, you said with respect to ground, it is at rest with respect to ground. Can you please tell me how is it possible? How is it possible? Super. T is equal to mg, then it will remain at rest. Suppose if T is greater than mg, it will have an upward acceleration. If T is less than mg, it will have a downward acceleration. What happens when T is equal to mg? It will stay there only. Meanwhile, thread pass through the pusa and all that, but it stays there only. Now, what is going to happen? mg minus T is ma. mg minus mg is equal to ma. So, therefore, acceleration is 1 minus small m by capital M. Can you please tell me which case this will come under? The ball remains stationary with respect to ground. Now I'll take up the other case. Stupid question. It is as same as before last Atwood's mission. Left side capital M mass, right side small m mass. Hello, boys and girls. Atwood's mission, simple pulley block system. Then you know what is the acceleration of that system. It is as same as capital M, small. So in this case, what is going to be the acceleration? Capital M minus small m by capital M plus small m times g. Done. Any doubts? Boys and girls, are we clear? Right. Soumya is absent today. And try to please understand. I am giving it two observations. ఒరే నువ్వు ఫ్రెష్గా వచ్చావు, బయట నుంచి వచ్చావు, సరే క్లాసులు వినలే. క్లాసులో టీచర్ చెప్పేటప్పుడు వింటే అర్థం అవుతుందా? ఇంటికి వెళ్ళి నోట్స్ చదువుకుంటే అర్థం అవుతుంది. టీచర్ చెప్పేటప్పుడు డైరెక్ట్ బుర్రకెక్కుతుంది. మీరు ఏ రీజన్స్ వల్ల ఒకరోజు మానేసినా కూడా దట్ ఈస్ ఎ గ్రేట్ లాస్ ఫర్ యూ. రైట్. నెక్స్ట్. Done. All inclines tomorrow. I'll close tomorrow. Inclined, all inclined tomorrow. This already I have taught. Lot of models I have taught. Fine. Yes, this is my problem. Go through this question, everyone. Boys, come on. Given the setup shown in the figure, block A, you can see the block A. Here is the block A. Block A, block B, block C. Right. Now you have three arrangements. There is no friction between B and Ma. Thank God. But the friction unte em bhavana correct ena? This is a difficult question. And thank God there is no friction between the block B and the floor. Era Vishwa correct ena kada? Right. అందరూ అలాగే బద్దకస్తులే నా స్టూడెంట్స్ కూడా. Our afternoon class is excellent class. 3-block problem I will discuss. Right. Okay. Our major time I am spending here. I should spend some time there also now. Right. Next. Yes, what do you want? In terms of the given data, find the acceleration of block A. Tension in the string connecting A and B. Suppose Gatra and all that. It's a different story. First, I will respond to A. Is that okay for you? So for this purpose, free body diagram is required. Right. Now, right. What is this? Block B. What are the different forces on this? Tension force T1. Can I ask a question? Honestly, do the tension in this string as well as the tension in the string be same or different? Why? Can you please tell me in one word? A different string. They were separated by a massive object. That's the reason. Right. Okay, your feelings are correct. Expression is wrong. Right. T1. So this will experience another force T2. And I told you a lot of times, whenever problems are given, first try to evaluate normal reactions and frictions. So you have C here. This is a C. T2. Obviously, for A to move down, the only possibility is C to move leftwards. So on C, what is the direction of friction? F. So on B, what is the direction of friction? Right. What is the limiting value of this friction? Limiting value. The limiting value of this friction is simply mu mg. Right. Clear? By the way, all are connected like train compartments, type. All compartments will have the same acceleration, provided going in the straight line. So therefore, this is going to have an acceleration A. This is going to have an acceleration A. By the way, I forgot one out of all these. What is that? The free body diagram of A. What is the free body diagram of A? Which is nothing but mg tension T1, mg tension T1. Okay, na? So acceleration is A downwards. This is all known to you, know how to handle. What you will do, you simply draw the free body diagrams. Mg minus T1 is equal to Ma. What else? T1 minus F minus T2 is MB. What is the mass of MB? Small m. Small m A. By the way, the above T2 minus F is equal to Ma. Agreed, please? For each free body diagram, I have written one equation. The only possibility is that now you take the sum of all these things. Fat, 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 fat. So therefore, this is m minus, by the way, f is mu mg, minus 2 mu m g is m plus 2 small m a. So therefore, finally, to conclude, A is capital M minus 2 mu small m divided by capital M plus 2 small m g. I'm just asking again, any doubts? Pakka? Boys and girls? Actually, this is a simple format. First part is a simple format. For example, if they ask you questions like, for example, if they ask you questions like how tension, what is the tension, all that you can answer in no time. Now, all that you can answer in no time. You have every data. You know A, you can find T1, you can find, or whatever you want, you can now have it. Why? Because you have that acceleration term. Right. When will we do mistake? I'm telling you n number of times. When will we do mistake? When we compromise in learning, you will fail it. This can be given as a multi-correct answer type question. I have done elementary evaluation first. Then I stepped into the question. Are you noticing that? Next. A is done. Now, the major hurdle for me is to conclude B and C. Okay, when I trust my basics, I can do any problem. What is B? Read it. Suppose the system is released from rest with block C near the right end of the block B as shown in the figure. Okay, ba. If the length, okay. What is the speed of the block as it reaches the left end of the block B? Treat C as a point mass. Let me focus this. To do this problem, I should forget everything in the question. Everything and what to do on another except B and C. Right. Now I am drawing. I am changing the color. Did you notice the way I will change the color? Not that I have the provision of different colors. That is a different part of the question. This is a different part of the question. Finally, your printout contains all black only. Got it. Honestly, the lower block has a rightward acceleration. The upper block has leftward acceleration. I've said one thing, forget about rest of the world. Now, boys and girls, you are in the frame of B. Can you please help me? What is going to be the acceleration of C now? This is C and this is B. 2A. Why? Normally B is having this acceleration, C is having this direction. Relative added up. Please tell me here, have you understood that? Varun, clear. Varun Yanaka, clear. What right side? Clear. I know your name, I'll utter later. What about you? Have you understood? Why 2A? Right. సగం క్లాసులు వినవు నువ్వు, సగం క్లాసులు వినవు, రిలేటివ్ మోషన్ చెప్పినప్పుడు రాలా నువ్వు. Have you realized why every class is important? The acceleration of C with respect to A. అనేక ఇప్పుడు ఎందుకు అడిగానో అర్థమైందా? నేను మిమ్మల్ని పట్టించుకోవాలా? వెళ్ళిపోయా, వీడికి అసలు అది 2A ఎందుకో తెలియకుండా మిగతా ప్రాబ్లం ఏమర్థం అవుతుంది? యాక్సలరేషన్ ఆఫ్ C మైనస్ యాక్సలరేషన్ ఆఫ్ A. ఇది తెలుసు కదా కనీసం, రైట్? అండ్ దిస్ ఈస్ ఇందుకే C లెఫ్ట్ వర్డ్ మనం మైనస్ ఐ క్యాప్ అనుకుందాం, రైట్ వర్డ్ ప్లస్ ఐ క్యాప్ అనుకుందాం. C యాక్సలరేషన్ ఎట్టుకుంది లెఫ్ట్ వర్డ్స్, సో ఐ షుడ్ రైట్ దిస్ యాజ్ మైనస్ A I cap. What is the acceleration of B? B. B. What is the acceleration of B? Rightwards. So totally, what is this? Now you tell me, with respect to B, what is the acceleration of C? 2A leftwards. So relatively, how much distance is to be covered? L. Right? That's all. What do you want? You want time or you want what? You want velocity? No issues. Yes, S is equal to, 1 minute. V square minus U square is equal to 2AS. I can still use because constant acceleration. Final velocity V, it is starting from rest. 2 times 2A. You said 2A. Flow. You said 2A into S. S is nothing but L. S is nothing but L, ra? Why? Because you can see L. So got it. V is root 4 AL. I know what is A. I'll substitute there. Done. Next. Are you compromised? Even I can give you time also, no? I can give you time also. Time taken to reach also. How? Simple. S is equal to half A T square. A relative T square. S L half 2A T square. So the time taken is nothing but root L by A. So I have given you time and I have given you the velocity after reaching that point. Any doubts? Now, what is the third? The mass of the block A is less than some critical value. The blocks will not accelerate when released from rest. Stupid question, according to me. You want the condition when acceleration is 0. When A is equal to 0. When will A is equal to 0? Denominator has no effect. Numerator, if M is equal to 2 mu small m, what happens? Acceleration becomes 0. When acceleration becomes 0, it is edge of slipping, but won't slip. It is at the edge of slipping, it won't slip. At this instant, the friction is at the limiting value. What if M is slightly lesser than 2 mu m? Nothing happens. Even friction is also static. In the place of 2 mu m, you will write 2F. In the place of 2 mu mg, you will write simply 2f. Got the point? Sure? And one more important point. At that stage, tension on both the sides of the string is the same because equilibrium. Got the point? Right. Chalo. I have done this question. Any doubts, boys and girls? Is it really very difficult? Maybe lengthy, but not difficult. Are we clear? మా లాస్ట్ అమ్మాయి నువ్వు నిజంగా అర్థమవుతుందా? పక్కా రైట్. నిన్న ఈవినింగ్ వీడియో చూసుకున్నావా నువ్వు? మళ్ళీ బ్యాకప్ క్లాస్ అటెండ్ అయ్యావా? ఏం టాపిక్ చెప్పారు నీకు? ఈక్వేషన్స్ ఆఫ్ మోషన్స్ చెప్పారు. రైట్. గుడ్ క్వశ్చన్. ప్లేస్ చాలు. సూపర్ క్వశ్చన్. సూపర్ ఇన్ ద సెన్స్ గుడ్ మోడ్. కొంచెం జూమ్ చేయనా? Is that okay? Go through this question, everyone. See, when you are doing such questions, what is required is you must have the complete idea of each and every possible force on every possible entity of the system. Can you solve this question on the basis of one single formula? Even the previous one also is not possible. What I have done in the previous question, try to please recollect. I have broken the system into parts. A separate, B separate, C separate, identify all possible forces. And then I came to use some unification. So same thing here. Read the question, everyone. మీరు ప్రింట్ అవుట్ తెచ్చుకోలేదు ఇంకా. నా మొహం చూస్తే ఏమొస్తుంది? అందరూ తెచ్చుకున్నారు కదా. నిన్న పొరపాటు ఈ దీనిలోనే చెప్పాలి వాళ్ళు. Read the question carefully. Every part. Multiple parts. Let me start discussing on this. Here are three moving objects. Better start your observation with small m. Now, please try to understand what is happening to small m. For small m, this will have some tension force. Weight force. Don't forget there is a pseudo force also because I am doing all in the reference frame of C. So therefore, this will experience a pseudo force. and a corresponding reaction force N1. Is this complete or anything else left? నువ్వు చెప్దాం అనుకున్నావు యాక్చువల్గా మైండ్లో నీకు వచ్చింది, బట్ నువ్వు భయపడ్డావు కదా. చెప్పచ్చు, ఒకవేళ తప్పు అయింది కరెక్ట్ చేస్తాను నేను. ఏ డైరెక్షన్లో ఉంటుంది ఫ్రిక్షనల్ ఫోర్స్? చూసారా ఎందుకు డౌన్వర్డ్స్? ఇంకొంచెం బాగా చెప్పాలి అంటే టెండెన్సీ ఆఫ్ మోషన్ ఈజ్ అప్వర్డ్స్. So therefore, on this frictional force is downwards. This is my first achievement. Now you are observing A like this. Now similarly, you need to observe. Vishak, you tell me Newton's first law of motion first week. If someone misses, now do they feel this one really confident? That is the problem. Every class is important. So I have detailedly analyzed the situation. Right. Now hold on, no issues. Now we will draw the free body diagram of B. What are the different forces on this? The same tension. Why? Because it is the same string that is connecting both. You cannot change something like the weight. It always acts downwards. So what is the tendency of motion of this block? Downwards. Right. Can I ask a question? Bhaiya, this is action. Reaction acts on can I ask you, is that the only force on B? Yes, it will have a pseudo force again. A corresponding reaction force here, N2, and a corresponding reaction force here, N1. Is this the only force? Is the free body diagram complete? Is the free body diagram complete? నువ్వు భావనకు చెప్పడం కన్నా నాకు చెప్తే నేను బాగా చెప్తాను. నువ్వు చెప్పేది కరెక్టా కాదా? నేనేం ఎవ్వరిని ఏం వంటల్లా. మీరు తప్పు చెప్పినా ఐఎమ్ ఎంకరేజింగ్. చెప్పు. What? Okay, can you please bit clear, much more clear? Only my focus is on B now. నేను పులిదాకా పోలా. విశ్వక్, లక్ష్మి, సూపర్ రన్. అది వదిలేస్తే అట్ట ఏ డైరెక్షన్ లో ఉంటుంది ఫ్రిక్షన్? వై డౌన్వర్డ్స్? ఇందాక డౌన్ అన్నా, ఇప్పుడు అప్ అన్నా, ఏది కరెక్ట్? Direction of motion is downwards, so the friction between M and C is upwards. F2. Okay. Now see how much time I am spending on one single entity of this system. Right. Calculate the minimum acceleration A with which the system should be moved to the right so that the suspended blocks A and B can remain stationary relative to C. You want stationary. Or forget about, okay, right. Why should I forget about all? Now the issue is for A. sigma fx 0 because there is no acceleration. So in that case, n1 becomes ma. Any objections from your side? Boys and girls, any objections? Right. Sigma Fy 0 because you want rest condition. So what are the downward forces? One force is mg, another force is F1, upward force is tension. Equation 2. Any doubts? Boys and girls, any doubts? B. Sigma Fx is equal to 0. In this, Ma plus N1 is N2, which clearly implies N2 is capital M plus small m. Equation 3. Any doubts? Boys and girls, any doubts? Sigma Fi is equal to 0. Yeah, down is mg. And what are the forces on the upward direction? T plus F1 plus F2. Super. This is equation 4. Now, everything is left with the 2 and 4. Now, I am going to use 2 and 4. 4 and 2 implies mg is mg plus F1 plus F1 plus F2. M minus small mg is by the way, F1 is mu n1. Is this the same mu or different mu? All contact surfaces same. Thank you. Mu times n1 plus mu times n1 plus mu times n2. Any doubt? Boys, till this point. Till this point, any doubts? So therefore, this is nothing but capital M minus small mg is 2 mu n1 बोले तो me. N2 means, just now I have given N2 means capital M plus small ma. Finally, this allows me to write acceleration is capital M minus small mg divided by 2 mu m 3 times came. 3 small m plus capital M times. So that should be the answer. Any doubts? Boys and girls, is it really very difficult? No. So where lies my skill? Tell me, in this part of the problem or in this part of the problem? If I am good at free body diagram, I can write anything properly. Now you see today the coverage rate is high because one thing, I am spending more time on each question and I'm not allowing you to write because you allowed me to post that later and you will copy it again. No, see, because of this time, I am spending more time in analyzing the question. అర్థమవుతుందా? ఇది నేను ఫాస్ట్గా పోతాను, స్లోగా ప్రతి క్వశ్చన్ మీద టైం స్పెండ్ చేస్తాను. మామూలుగా మిగతా సబ్జెక్ట్స్లో రాసి మీరు కాపీ కొట్టి మళ్ళీ నెక్స్ట్ అయిపోతుంది టైం అంతా. నేను అది అవాయిడ్ చేస్తాను. రైట్. సిమిలర్ క్వశ్చన్. లెట్ మీ సీ హౌ మెనీ ట్రై దిస్. రేపు కనిపిస్తుందా? జూమ్ చేయాలి ఇంకొంచెం. In the given figure, the coefficient of friction between the walls of block of mass M and the plank of mass capital M is mu. The same coefficient of friction is there between the plank and the horizontal floor. You can see mu exists at two different, of course, you have one contact surface here, you have another contact surface here. The force F is 100 newtons. Masses given are small m and capital M, or are 1 kg and 3 kg fine. Find the value of mu if the block does not slip along the wall of the plank. Right. First thing, my very first step is I'll take as a whole the system as a single block. This is capital M plus small m as a whole. G. That is the opposition. And it has some acceleration A. Agreed? No, clearly F minus mu times capital M plus small m G is capital M plus small m times A. Agreed? So therefore, acceleration is who cares this? I am not asking about this. I am asking about what if. Now you draw the free body diagram of the smaller block. Draw the free body diagram of the smaller block. So you are in the reference frame of the bigger block. So tell me what are the different forces that you will observe. One is the weight force, right? What else? No, wrong. Don't come to friction straight away. What is the pressing force there? If there is no pressing force, there won't be any friction. Why there exists a normal? That also you tell me. Pseudo force. Come in order. So now there is a pseudo force. Why? Why there is a pseudo force? Don't forget you are in a frame which moves with an acceleration A. Pseudo force. So to cover this, you need a pressing force N1 called normal reaction. Now there is a pressing force. Now there is a source of friction. What is the tendency of the motion of small m? Downwards. So to oppose, what is the force required? Upwards. మీకు ఇప్పుడు పిక్చర్ క్లియర్గా అర్థమైంది ఎట్లా స్టార్ట్ చేసుకోవాలా సో వాట్ ఈస్ ద కాజ్ ఆఫ్ N1? Pseudo force. Now in this case clearly N1 is equal to MA and F1 is equal to mg. What is F1? Mu N1 is equal to mg. Mu MA is equal to mg. Correct? Okay. Now clearly A is mu A is 2. Now change the column. Now using 1 and 2 you can write as So, no, what do you want? Find the value of mu, no issues. I'll substitute the data. You said G10, అది ఇస్తే అంత ఇవ్వకపోతే అంత మనం రాసుకున్నది అదే 10 by mu. F 100. Capital M, small m, 1 and 3. Now multiply both the sides with mu. Which implies mu is a quadratic. It will have two roots. What are the roots? 5 plus or minus plus 16. And then 4AC. B square minus 4AC. Any doubt? Any doubt? By 2A. 4. నాకేమైనా తప్పు చేశానా నాకు చెప్పండి ఒకసారి. 16 ఎక్కడొచ్చింది? కాదు కాదు, బి స్క్వేర్ మైనస్ 4AC కదా. 4AC 16. Okay, thank you. Now what is the possibilities are 5 plus 3 by 4 or 5 minus 3 by 4. 5 plus 3 by 4 gives you 2. 5 minus 3 by, so which means in other words 2 or 0.5. Both are possible, but generally practically mu 2 is meaningless. Mu 0.5 is okay, but mathematically 2 or 0.5 both are possible. Both are real roots. So practically we will choose mu as 0.5. Mu can be 1 also, but whether mu 2 or not, practically unimaginable. Mu can take value of 1, but 2 unimaginable. So practically speaking, possibility is 0.5. But you should write 2 or 0.5 in reality. Any doubt in this? Clear? Everyone in the class? Right. Shall we proceed for the next question? Pakka? Any step you have doubt, please ask me now. See, this is the question gets repeated both in SC Verma as well as in our study materials also. I'll give you time for this. Work and see that you get that answer. Now you take the system like this. Now see, suppose if there is no friction, what happens? M comes down, capital M moves rightwards. Agreed? So therefore the tendency of motion of capital M is rightwards with some acceleration. Right. Now I am drawing the free body diagram of M. Now you will have an acceleration A. I assume E. Right. And one more important point, you know, by constraint relation also you can give the acceleration relation. Actually, this is A relative. By constraint relation, you can give how? Suppose if this distance is X and this distance is some Y naught, and an instant this is at a distance y. Can you please give me the length of the string now? Length of the string is x plus x naught plus x plus y. So what do constraint equation gives? 2x plus y plus x naught is L. Differentiate this. So 2 times d square x by dt square plus d square y by dt square is 0. Remember, this is decreasing and this is increasing. So 2 times minus 2 times acceleration of 1. We'll call this as a 1 and we'll call this as a 2. So that there is no confusion. 2 times acceleration of 1 plus acceleration of 2 with respect to 1 is 0. Therefore, the relative acceleration is 2 times the acceleration of 1. This is drawn from last week concept. This is the constraint. Now, I'm asking you honestly, how many started with this? I think no one in this class. Why I will explain. You will draw one free body diagram for this, another free body diagram for this. 2 equations. But how many unknowns are there? The acceleration of this is different, the acceleration of this is different, and the tension is another unknown. Now, if we have 3 unknowns, how to find with 2 equations? Tell me. So, therefore, constraint relation is one of the equations. Now, you start this as A21 is 2A1. And this is mg. This will experience a pseudo force ma1. And this will experience a normal force n1. Got a point? And apart from this, what else? The other forces that you will see, one is the tension force. The other is friction. Which direction? Friction on small m. Upwards. Why? Tendency of motion is downwards. నేను ఇట్లా వై అని ఎందుకు అడుగుతూ ఉంటానో మీకు ఏమైనా అర్థమవుతుందా? యు ఆర్ క్వశ్చనింగ్ యువర్ సెల్ఫ్. యు ఆర్ లెర్నింగ్ పర్ఫెక్ట్లీ ఓన్లీ ఇన్ దాట్ అకేషన్. Right. Done. Clearly, I can write N1 as MA1 and mg minus t minus f is m times 2a1. Right. So friction is mu n1. So therefore mg minus t minus mu1 ma1 is 2ma1. Let this be equation 1. Right. Any doubt? Boys, any doubt? Now, what is your next focus item? Your next focus item is the capital M block. So, on capital M block, you will have different forces like this. Here, this is action. You will have reaction like this. And this is the tendency of motion. So, you will have friction like this. And you will have a tension force here and a tension force here. So, sigma fx condition gives 2t minus n1 minus f2 is, here one more force, n2. is, अरे यार 2t minus n1 minus f2 is ma1. Let this be, if you still have doubt, please ask. Equation. Now what is n2? n2 is nothing but mg plus f1, mg plus mu1 ma. So done, n2. Right. Now you take up this complete relation again. 2t minus Maruti. Very good. Very good. Right. Winner. Okay. Class right. N1 MA1 F2 mu N2. F2 is nothing but mu N2. And mu is nothing but mu2 here. A1. Boys, you have one more equation here. You please try to write this properly. Minus, you knock all A1 terms the other side. Yeah, what I got is minus Or yeah, I have done anything. I multiplied 2 with equation 1. So why I have done in this process is 3 is nothing but 2 times of equation 1. You just add 2 plus 3. Fortunately, you are relieved from this. Now what is happening is 2mg minus mu2 mg minus mu1 minus mu a1 minus 2 mu1 ma1 is capital M plus 3 small m a1. Now you bring all a1 terms one side now. And that is 2mg minus mu2 mg done. All a1 terms one side. Are capital M plus 3 small m plus 2 mu1 m plus mu1 mu2 m all put together is a1. Remember, that is the acceleration of the block. Now just work on this. I repeat, first step is from the free body diagram of this. Second step is from the free body diagram of this. I have framed all possible equations from here itself. All possible equations from here itself. Right? In such a questions, what are the sources of mistakes? Can someone tell me what are the sources of mistake? You will identify proper free body diagram. You will draw all possible equations. The source of mistake that you will do is calculation. You will do blunders in calculations. Consequence, you will finally fail to reach the answer. So solve this, you will get the answer. Any doubts? Right. The next question. A man of mass m is moving with a constant acceleration a with respect to plank. The plank lies on the smooth horizontal floor. Very good information. There is no friction, which means, yes, ఎక్కడైనా మిస్టేక్ వచ్చిందా? 5m. ఇంకా చాలా ఉన్నాయి, ఇంకొకసారి చేసుకోండి అది క్యాలిక్యులేషన్. అవును, అది కూడా తీసుకోవాలి. అది ఇప్పుడు చెప్తావేంద్రా? అంటే అప్పుడు ఇంకేమో యాడ్ చేయాలి నేను అప్పుడు? N2లో యాడ్ చేయాలి, +t యాడ్ చేయాలి. ఇంకొకసారి జాగ్రత్తగా చేయండి ఈక్వేషన్స్. నేను జస్ట్ కాన్సెప్ట్ చెప్పా కదా, ఇంకొకసారి జాగ్రత్తగా చేయండి, ఎందుకంటే టైం వేస్ట్ అవుతుంది నాకు. కాన్సెప్ట్ ఇచ్చేసాయి కాబట్టి N2 సబ్స్టిట్యూట్ చేసి మీరు నేను మీకు జస్ట్ క్లారిటీ ఇస్తాను, జాగ్రత్తగా ఫాలో అవ్వండి. ఈక్వేషన్ 2 ఫ్రేమ్ చేయటమే చాలా కష్టం. ఈక్వేషన్ 2 జాగ్రత్తగా రాసుకుంటే ఏమొస్తుంది చెప్పండి? 2t - ma1, మరి ఎక్కడ దాకా ఇష్యూ ఉందా? -μ2 n2 అంటే mg + μ1 a1, ఇంకో టర్మ్ యాడ్ అవుతుంది యాక్చువల్గా దీనిలో. ఏంటది? సో ఫైనల్గా ఇది a1. ఇది కొంచెం జాగ్రత్తగా రాసుకుంటే మీకేమొస్తుంది అంటే 2t - ma1 - μ2 capital MG minus ma1. Equation 2. Equation 2a otherwise. Now what you need to do is the tension of equation 1 substitute in equation 2. You will get table. It's a jumbo equation. My role lies in concluding at 1 and 2. If I stay on that, I couldn't complete more problems. My target is minimum 20 questions today, but I didn't do. Anyone just please give me a count of how many questions I have done today. I didn't even cross the 10 if I am not mistaken. Chapara 6 slow. This is the plank. Here it is smooth. And relative to the plank, he is moving with a acceleration. What is the frictional force exerted by the plank? Fortunately, both are of same mass. See, please try to understand how the man gets acceleration. Some frictional force should act in the forward direction. That provides A acceleration to him. A dash A1 acceleration to him. Arey, don't get confused. It is not A. A is the acceleration with respect to the plank. Now for the plank, अरे भैया ये action है, though this will reaction and it gives, by the way, this is mass m, this is mass m. Now this will give you another acceleration A1. Why I have written A1? Common sense. When F force acts on M, giving A1 acceleration, when the same force acts on a similar mass, gives the same acceleration, but in the direction of the action of the force. So, which implies the acceleration of the man with respect to plank is acceleration of the man minus acceleration of the plank. You have given this as A. Anything which is directed left hand side, we will represent with minus I cap. Acceleration of the man. What is the acceleration of the man? You said the acceleration of the man is A. Acceleration of the man with respect to plank is A. And acceleration, just now we have mentioned, no? A1 times minus I cap. Acceleration of the plank, A2 times I cap. So A is 2A1. A1 is A by 2. If you ask me, actually, the man is having an acceleration A by 2 with respect to ground. Similarly, the plank is having an acceleration of A by 2 with respect to ground. Any doubts? Most repeated question. Even in mains also, you may be given this question. The most repeated model. Next. Yes. Now you try this question. What you can see there is you have a plank of mass m is placed on a rough horizontal surface and a constant horizontal force F is applied on it. Man of mass m runs on the plank. Coefficient of friction between the plank and the surface is mu. Assume that the man does not slip on the plank. Find the acceleration of the man so that the plank does not move on the surface. Now try to see what is happening to the plank. Constant horizontal force is applied on it. Man of mass m runs on the man. See, two possibilities are there here. One possibility is, if the man is running with an acceleration, one thing is clear, friction may take this direction. Remember, plank is not moving in this case. Can you please help me in writing F2? Yes, obviously, what is the normal reaction here? Weight of both the blocks. So therefore, this is the picture. Any doubt till here? Bhaiya, the same F1 provides Ma2 man. So therefore, this is the limit. That is case 1. Any other case possible? No change in this. This is also possible. No? That is also possible. So in that case, that is also possible. And one more case is also possible. First, F2 may become 0 also. In that case, F1 becomes capital F. So therefore, any acceleration between any accelerations between these limits are possible. F by M is also possible. When F1 is equal to capital F, it is possible. See, friction changes its direction, so long it is static, it can change its direction, self-adjustable. Now, do you have any doubt in this? Right. In the afternoon session, if time permits, I'll discuss this question. Some models related to higher end one. I'll discuss these questions in the afternoon. This one I will discuss. This one I will discuss. Right. 1 hour, 6, 7 questions maximum. Right.